Well, hi, good morning. Welcome to my shop, and thank you for joining me again for another. This is actually day 2 on this radio. So what I've done here is I'm just gluing back the antenna to its support here. As floppy and flimsy as that is, just a loose screw down below here. So you might want, what do you use to glue that? Nothing special. I'm just using the Gorilla Guide to do it. Not promoting this product in any way, shape, or form, except that's what, just in case you wondered, did I use some kind of special radio glue? No. Okay, this has to remain clamped for quite a while, so that's just going to have these extra wings on this radio for a bit. What to do next? So far, the radio operates, doesn't seem to receive very well at all. Could be from all sorts of things. Probably a good place to start, though, is with the output tube bias and checking to see that that's in order. How am I going to turn this radio upside down now? Or sideways? I've got these things sticking out. The challenges. The challenges. Well, let's take a look at the schematic for this radio. It's a bit of a bare bones schematic here. A couple of things we should look at right away is how is the power line dealt with in this radio. And you can see a capacitor here. Let's just zoom in a bit. A small capacitor here. On the other side, the switch. So this would be, he says with a weak voice, B minus. This would be the B minus line here. And how are these tubes, heaters, getting their power? So one is from here. When the switch is closed, there must be a dot not visible here. There must be a dot right here. This line must be connected here. Well, where's that going? And that goes up. Oh, the heater here. Okay, where's the other heater? There we are. That's how it works. Okay, so we got 4 tubes lined up here. The last one is showing up here. And that's how it finds its way back. No dot here. Okay, so we have a B minus line. Now, how is this related to the chassis? So I'm looking along the B minus line for evidence of a connection to the chassis. Yikes. So I don't see anywhere where it indicates how the chassis is dealt with except for this. So we could assume this is a connection to the chassis. I don't think there's any indications of how they've. Oh, here it is. Here it is. Okay, this is probably the shield of these 2 tubes. What about the guy in the middle? So in this radio is 3 metal tubes, 2 glass tubes. The rectifier and the output tube are glass. The other 3 are metal. There's 3 metal tubes in here. These 2 show what so look what they've done here. They've darkened this part of the diagram just right in here. Done the same thing in this spot and done the same thing in this spot. So assuming that what they're marking here is the key that's on the bottom of the tube. This would be pin number 1. Pin number 1 is often the shield. There it is. It's all adding up nicely. This would be pin number 1. This would be pin number 1. Oh, you know what? There's a dot right there. That's what happened. I didn't see the dot. Okay, so the shields are all hooked up to here, to this wire, which is then has a capacitor, and then it goes to the chassis. So this is the important one. This one here is the one that's draining the chassis through this connection, and has to do with safety. with your own personal safety with this radio. If this is shorted out, and this is a non-polarized plug, right now it's just two wires hanging out the back. There's not even a plug on it. In this case, I'll put on a polarized plug, and I'll try to control the connections here to provide the highest level of safety in the radio when I do it. But in the older days, these were not polarized plugs. There was no such system. You could plug it in this way or that way, and so the radio was built to accommodate that as best as possible. And part of that was this capacitor. So we would want to find this one fairly early on. Nothing else is connected to the chassis I can see in here. There's no other ground symbols anywhere. Okay, that's settled. Now let's take a look at the output tube. It's a 50L6. The cathode has a cathode resistor and a bypass on it. I've replaced this bypass already. It's one of the three capacitors that I replaced. We don't know if this 150 is still 150. We would need to check that. And most importantly, this capacitor here. This one is trying to allow the signal, the audio signal, to come through and reach the grid here, but at the same time block the plate voltage that's sitting here. Now, there's usually not very much plate voltage here, 50, 60 volts, something like that. But if this is leaky enough, that pressure difference will cause some charge to move over this way. And this is a 500,000 ohm resistor here. And so this would build up a charge, would actually push the grid positive, because this is positive out here. So the grid would be pushed positive. Now the bias is being provided here. It's probably 7 volts, somewhere in that range. So you could tolerate a volt or two of the grid being pushed positive, and the tube would still operate fine, and you wouldn't notice anything. But what would be happening internally is more and more current would be flowing in this tube, yet not generating any sound in the speaker, but just kind of wasting away, flowing through here, burning the cathode, burning up the cathode, or wearing out the tube quicker than desired. Now, if this gets really bad, if this was really bad, and this got pushed far enough, the sound would be distorted in the speaker, and it would be obvious that something has gone wrong. But the early stages, you wouldn't notice anything. Oops, anything going wrong. So we want to find this capacitor, we want to find this resistor, we want to check the bias voltage across here, we want to check the grid voltage here to see if it's drifted high, and that's what we need to do. Then we need to replace this, and maybe this resistor here, maybe. Okay, that's the plan. Okay, very good. Now, what we want to do is figure out which capacitor is that grid blocking capacitor and figure out where we are in this radio. At the same time, I don't want to disturb my glued up antenna too much. So let's tip it up like this. The output tube is right here, right here. I say 1, 2, 3 capacitors in the area, 3 big capacitors. It's on pin number 5, so if we count them, there's the key there. 1, 2, 3, 4, 5. This is 5. This is 5 here, and there's a capacitor connected to it, and it's going over to this tube. And I'm pretty sure that this would be the detector tube, audio output from the triode in it, over to here into the output tube itself. So this has got to be the guy right here. Hey, front and center. That's a pretty easy one to get at. That's a lucky break, except it's down there. Okay, I think I can fix that. Once again, trying to not disturb my antenna. It has to hang a little lower here. That's not stable. Well, no, it isn't. There's something up in here. That's pretty stable. Okay. There we go. Now it's up here. Excellent. Let's cut it out and we'll give it a test. Oh, no. Don't. You're going to miss an opportunity here, Jim. let's run the radio, make the readings, see what the bias, the cathode bias voltage is, see what the grid voltage is here, and I think I'll try employing my super high input impedance meter to do this. First though, coffee is in order. Okay, just about ready. So we're going to be using this meter. This meter has a very high input impedance, 120 megohms, I believe. That's why we're going to try using it. 2 probes. This one's got to go on to the B minus, not the chassis, but the B minus point. So a good place to find the B minus point would be to look at these capacitors I put in, and the negative terminal for these 3 capacitors here, and the negative terminal follows a wire right up to there. So there's a good spot to put this, right there. Now, radio's not plugged in any way, and when I do plug it in, it'll be plugged into an isolation transformer, so that reduces some of the concerns here. So this will be my test probe, and I'm going to practice here. I'm going to want to go on the grid of the output tube, which will be right here, like that. And then we will read the voltage over here. You're expecting a 0. Actually, I'm going to start with the cathode. Cathode is probably pin number 8. Let me just check here. I'm just going to peek at the schematic, since I know the key, the schematic, and the cathode is pin number 8. That's right, pin number 8. Okay, and we find pin number 8 just by the key here. The tube key. So pin number 8 is that one. So we'll practice here. I don't want to do this. Okay, the expectation here will be a positive voltage on the meter, somewhere around 6-7 volts, something like that. I'm on a 10 volt scale, so 10 volts over here. This meter takes a while to warm up. Just setting the 0. Okay, we're ready to go. I'm all set to go. Okay, so I guess we got to plug this in to make it work here. Just making sure power cord is still safe. Yep. Okay, so we're going to do the dim bulb thing as usual, and here we go. Everything ready? Yes. Yeah. Okay, so I don't have the switch on. Let's put the switch on here. Yep, sure enough, a little bit of volume. Here we go again. That's a little better. Okay, that's the heater current dropping. Now the heaters are heating up, the rectifier is starting to work, high voltage is being produced, and now the tubes themselves begin to conduct, and the light bulb gets brighter. And we hear some sound, and the light bulb gets brighter. And we hear some sound. There it is. Light bulb's getting brighter. Okay, that's normal. That's perfect. So the actual voltage reaching the radio now is under 100. That's a little low for doing these tests. We really want a more regular voltage. So I'm not too scared about this. I'm going to get rid of the dim bulbs, and we'll put this up here. Quickly see what we get. 108. Go just a little higher. Okay, 112, that's going to be good enough there. Even a little bit higher yet. 114. Okay, we're ready. We are ready. First thing is tube bias. We're set on positive. Upscale reading for positive voltage, expecting 7 volts, so the meter should come up somewhere in this area here. Okay, let me just get down here. Count them again. No, don't have to count them. Pin number 8. There we go. So the voltage is 7 volts. That's pretty much perfect. Okay, now the next voltage we want to read is on the grid. I'm using this meter because of its high input impedance. It won't drain out the grid potential, give us a false reading. I'm expecting a 0. It doesn't really matter where this is set. I'll leave it on. Oh, it should be set to positive because it's a positive voltage that may come over. So we're on the 3 volt scale now. If everything is perfect, the meter's not even going to move. If everything's perfect. Here we go. Right here. Oh, whoa, whoa, whoa. We got 3 volts positive there. Yeah. Well, that's not good. So that has to be because of some charge leaking through this capacitor here. And now I'm going to find out if I'm telling the truth, because I'm going to replace that capacitor and we'll check it for its leakage using a qualitative test. In fact, I can do that right now. Just cut it out of here. Parents used to say that to me a lot. Cut it out. A lot. I got that a lot. Cut it out. And they weren't talking about capacitors and old radios. Okay. Now I think I can see where this came from, but because I know how stupid I can get about this, I'm going to put a clip lead on here just to mark it. Okay, there we go. Take this guy. Pretty dirty. I don't know if that really has any impact on it. And it says, I can't read it. It should be a 0.02. No, looks like a 0.02. Okay, let's go over here to the testing area. And we will apply the test. So the weather report today here is gray and cool. Maybe some sunshine later in the afternoon. I live in a very sunny area though. This area is known for being sunny. Not today. Okay, 50 volts. Now, I'm going to put 50 volts on the capacitor. If no current leaks, this eye will look like it does now. It's open here. This pi is open here. If it leaks, the pi will be closed. If it leaks badly, the pi will close right up. 50 volts. This is the first capacitor from that radio. Typically a radio that age, that kind of condition, these capacitors are quite leaky. I believe it's from moisture ingress over time. So let's give it a shot. Here we go. 50 volts. What do you say? So it's open part way. But surely to goodness on 150 it's not going to open at all. So, you know, as capacitors go, in these old radios, this is typical. Very typical. And you saw the voltage that was on the grid, apparently from a leak through here. Now I'll put a brand new capacitor in that doesn't leak at all, and we'll find out if that voltage is taken care of or not. So what's happening here is you're using a cathode resistor to raise the potential of the cathode. So here's the grid and the cathode. This is the grid here. Okay, there's the grid. Make a G. That's a G. Can you tell it's a G? So what's happening is you want to bias them. You just want a difference in potential between these two. It doesn't matter if it's down here or up here, as long as there's a difference. And you want the grid to be negative. So I'll show that this way because that's typically. So you want grid. So one way is to push the grid negative, but another way is to push the cathode positive. And that's what's going on in this radio and many radios. The cathode is lifted positive by that cathode resistor. But what's happening in this radio is a leak is putting a charge into the grid circuit and it's coming up. So ultimately the bias is half what it should be. Instead of 7 volts, it's around 3 volts or something like that. At 3 volts, this output tube will be conducting unnecessary current, and that's going to cause unnecessary wear on the cathode. The cathode has a material that wears off over time, is consumed over time. For reasons I don't exactly know, but we can guess. It's made red hot, and chemistry happens when things are red hot. Okay, so I'll put another capacitor in there, and we'll give it a good test. maybe I'll take a moment just to explain a little further. Now, I mean, if you do this kind of stuff, you know all these things. But if you're new to all this, you may not know, like, why even bother biasing the tube in the first place. Why do you want the grid to be negative? What's the reason for that? And it's to give room for the applied signal. So the grid relative to the cathode, it never goes positive. As soon as the grid goes positive relative to the cathode, it looks like a plate. It looks like a place for current to go, and that's what will happen. Current will go into the grid. And that current will be lost from the main current, and it's going to show up as distortion and lead to other problems too. You just don't want that happening. So basically, you're biasing the grid to make room for the signal that's coming along. So the signal stays below, stays negative. If you let this drift up, like in this radio, and you apply a signal, if the signal is loud enough, it will rise above the cathode voltage, if I can put it that way. It's maybe not the best way to put it. And every time it does, grid current and distortion. Exactly what that would sound like, it'd probably be fairly subtle, unless it's really bad. It probably doesn't sound bad unless it really sounds bad. So I don't like explaining things in too much detail. I really think there's many other videos on YouTube that can go into these kinds of things in depth, so I'm happy to run into issues and kind of comment just a little bit on them and then catch your interest. Off you go, watch some videos, read some books or something like that. I don't like to try to explain things I'm still trying to explain things to the bottom for myself. There is no bottom. There's no bottom. One of the ways that I'm trying to get to the bottom of things in my life, because I'm interested in, how did we all get here, what's with the universe, all this kind of stuff. I'm interested in those foundation answers, if you like. So I watch a lot of videos of physicists, like known physicists, and they're being asked very interesting questions, very fundamental questions. And what I've come to realize is that up here where I am, looking at the world without the benefit of the tremendous knowledge that some people have on this kind of topic, and I'm kind of baffled. I'm just baffled by how it all came to be and all that. It's very baffling. It's very, very hard to accept even that we're here. It's really difficult. And I don't have a big depth of knowledge. So if you follow these people with the big depth of knowledge, and they're much closer to the bottom, well, they're just as pulling their hair out just as much as I am, up where I am up here. I mean, up where we all are up here. We don't really understand. But these guys, they're pulling their hair out too, because they've gotten to a new bottom, a bottom we might not understand well, maybe one that's described best by mathematics. And it's full of things that they can't accept, and they wonder, like, the multi-universe and all these other issues, Schrodinger's cat idea, all that stuff. Even the famous, even this thing I learned in high school, for crying out loud, and that's the double slit experiment, which I won't go into, but you probably know about it. I mean, most people do, I think. What they don't realize is that there is really a poor explanation for how that works. When you get right down to it, it still makes even physicists scratch their heads about what is going on there. So, yeah. So that's why I say there is no bottom. There is no bottom. There's just what do they say? It's turtles all the way down. That's the right answer right there. Okay, enough of that. Let's see what happened here. So we'll turn the volume down a little bit. What do I expect has happened? I expect that the grid will be at 0 volts now. Remember, there's a resistor connecting the grid to the B minus, but it's a large resistor, 500,000 ohms. So it wouldn't be too surprising to find the grid at 0 relative to B minus, because it's connected to it basically. Okay, power on, volume is set up just a bit, going through the dim bulbs. Yes, where in the world is truth? What is the truth? What is the truth of us? Some people could care less about this kind of stuff, but this has haunted me my entire life. I have always been interested in all these basic fundamental questions, and for me personally, religion provided nothing to help me think. I understand what's going on. Let's see what's going on with this radio now. Yeah, I don't want to knock religion, but yeah, I do. I do want to knock it. Okay, we're on a positive setting, but it won't really matter because I'm looking for a 0. We should see no effect on the meter. I'm on the 3-volt scale there. Right here. Okay, come on. Now, sometimes this doesn't work. 0. 0. Very good. And we're going to look for the bias. Make sure I'm not... what am I doing here? 93 volts. Let's give it the full voltage here. We'll try again. But I imagine it's still going to be 0. Popcorn. It's still 0. Okay. What if I put this right down to 1 volt? 1 volt. Does it still look like 0? That's kind of odd, wasn't it? It kind of came up very, very, very slowly. As if the voltage was building up as I was measuring it. Try that again. Whoa, what's going on here? No, there's nothing there. Jim, what's happening? Maybe I touched the wrong yeah, don't try others. I'm on the 1 volt scale. Oh! What happened there? That's a weird one. You touch right onto the actual tube pin. Nothing. Weak connection? Did I not solder this well? Okay, let's read the bias voltage on the other side of that capacitor. The bias, the plate voltage over here. She's coming in at about 60 volts. 60 volts on one side. I don't know what that reading was. Just add it to my list of weird things that happen. Oh, and we wanted to read the cathode voltage, and I forgot about that. 10 volt scale should be up around here again. By my memory of it. Okay. Here it is here. And it's right in, it's 0.6. It's 6 volts. So we have the proper bias on the output tube now. Again, it's a little hard to, Why so crunchy? So I'm going to loosen this up because it's so tight. We're going to do it with a little bit of WD-40 here. And I just want to get it right on the back of this part. Ooh. It does sound like a capacitor rubbing as well. That's just too loud. That's a very shrill sound. Hey, picking something up. Okay, so if we go to where there might be a state, not very good. Here we are. Something rubbing somewhere. This didn't come very loose in the oiling. Maybe a little bit better. There's more restrictions in here. Okay, we switch off. So I removed basically a risk in this radio, the risk of early death on the output tube. They haven't tested the tubes on this radio either, so we don't really know the condition. Got the power off here. That's it for today. That's all I'm going to do today. Tomorrow we'll just carry on with another step along the way, and we'll see what happens. Thanks a lot for watching, and we'll see you on the next video. Bye bye.